So this is the 2020 fall semester final review. Not going to play around with this. Take your time, read the directions on the final. Make sure you understand the directions on the final before you begin. Question 1. Mr. Tannenbaum has a 15.2 by 11.4 monitor on his computer. After purchasing an HDMI cord and hooking up his computer to a 65-inch TV, the rim of the picture did not show up on his TV. This was because A, he did not put it on the full screen. B, the aspect ratio of the TV, 16:9, does not match the aspect ratio of his computer monitor. C, the aspect ratio of the TV, 4:3, does not match the aspect ratio of his computer monitor. Or D, new TVs have a default that will only receive 90% of the computer screen. Okay, so this is a new TV. If you want to check, the old TV is, you use your calculator, you can check it by looking at the 15.2 inch by 11.4. The 15.2, remember, on the TV aspect ratio, WL, the width is always longer than the height that comes, or the length, and the width comes first. So 15.2 is the width, and 11.4 is the height. You got 15.2 for the width, and 11.4 for the length. Well, what's the aspect ratio of this TV? That is, it is 15.2 over 11.4. So 15.2 divided by 11.4 equals 1.33. Well, guess what else is 1.33? 4/3. So the aspect ratio for this TV is 4/3. Okay? So it's an older TV. It's one of those 4:3 aspect ratios. The new TV is a 16:9 TV. Well, let's talk about that here real quick. We see that if it's a new TV, the aspect ratio of the TV is 16:9. It doesn't match the aspect ratio of this computer monitor. That is our answer. That's our answer. Okay? So let's move on to question 2. Circle the correct aspect ratio for ratios in the media. Guess what? We just described that width always comes before length. All right. So let's talk about changing tires. Use the following information to answer questions 3 through 4. Actual mileage, which is K times odometer reading, which is your mileage from your reading. Actual speed is K times the speedometer reading, miles per hour. And where K equals the circumference of the bigger tire over the circumference of the factory installed tire. So 3, if the odometer reading is 8,000 miles on your car and you have tires with a circumference of 103 inches, you've actually traveled how many miles? Factory installed tire circumference is 93 inches. So this actually is a really simple answer. So I'll show you real quick. We have K equals 103. Let me make that equals over 93. Okay, so K is 103 divided by 93, which is 1.1. Okay, so if our actual miles equals K times reported miles, then the actual miles, 1.1 times 8,000, which was the miles that was reported. So all we have to do is multiply 8,000 times 1.1. And that gives us 8,800. So we're going to write that answer in. It's 8,800. That's what goes here. Okay? But if the speedometer is reading 40 miles per hour in your car and you have tires with a circumference of 103 inches, you're actually traveling how fast? And it's the same thing. Factory installed tire circumference is 93 inches. So we use the same K value. And instead of multiplying by 8,000, we're going to multiply by 40. Find out the speed. And it's K times reported. The actual speed, 1.1 times 40. Guess what? 1.1 times 40, 40 times 1.1 is 44. So the actual speed is 44 miles an hour. What is the aspect ratio for the tire P195/60R15? So there's three parts of the tire. That is the width in millimeters. That is the height of the rim in inches. And this right here is 60. That is the aspect ratio. So the aspect ratio for that tire is 60%. That means that the height of the tire in millimeters is 60% of the width of the tire in millimeters. All right, so you're standing amongst a crowd that is 5 foot deep on a 1.5 mile long parade. You want to estimate how many people are there. If each person occupies 2 square feet, estimate the size of the crowd watching the parade along a 2-mile stretch, both sides of the street, and there are 5,280 feet, 1 mile. Okay? You're standing amongst a crowd that is 5 feet deep on 1.5 miles long. Okay, so this 1.5 miles long, it's actually there just to confuse you because we're talking about a 2-mile stretch, both sides of the street. So hypothetically, whether or not the parade route is 1.5 miles long or not, we're talking about how many people could fit if there was 2 miles. So we got to look at that from a different perspective now. It's 5 feet on both sides, and it's 2 miles. One person equals 2 square feet. Okay, so this is 2 miles, and this is 5 times 2, or 10 feet, because it's both sides, remember? So we need to find the area. We already know that one person equals 2 square feet. Well, how many 2 square feet are there in this area right here? Okay, 2 miles is actually 2 times 5,280 feet. Okay, so that is 10,560 feet. Times 10 makes it 105,600 square feet. Okay, we're just going to divide that by 2. 2 square feet equals one person. So we divide the 2 that the person takes up the space into the space that the whole area is to find out how many people will fit in there. So 2 divided into 105,600 is 52,800 people. So question 7 says, create a Venn diagram to answer all the questions for the following answer. Okay, so a marketing class polled 150 people at a shopping center to determine how many read the daily news and how many read the weekly gazette. They found 95 just read daily news, 31 read both, and 10 read neither. So let's talk about this. But we have 150 people. So let's add that total up. How many do we have that we know where they're at? We got 95 plus 31 plus 10. We have 136 people total that we already know about. The last one we don't know about is who reads just the Weekly Gazette. Weekly Gazette only is 150 minus 136, which is 14 people. So there you go. That's how you make that Venn diagram. What is the probability the person only reads the Weekly Gazette? Okay, so 14 out of the 150, probability Weekly Gazette only, 14 out of 150. Okay, next question. What's the probability they read the Daily News and the Weekly Gazette? Well, let's see. Weekly Gazette and the Daily News reads both. That's 31 people right here out of the 150. Okay, probability of both. Okay, probability of both, 31 over 150. All right, what is the probability a person reads neither? Oh, well, this actually makes it pretty simple. We know that 10 people don't read either, so it's 10 out of the 150. And you can find the answer for that by reducing it, changing it to a decimal, or making it into a percentage. Okay, so let's move on. Next question. Use the following scenario to answer questions 11 through 13. Kayla plays chess. Next week, she'll be competing in a tournament in which she'll play 4 games. To win a trophy, she must win at least 3 games. How many total possible outcomes can she have when she plays her 4 games? All right, so the best way to do this is to create a tree diagram. Okay, so she's going to play chess. Either she wins or she loses. So she's going to play 4 games. Let's look at what that looks like. Okay, so the question is, how many total possible outcomes are there? Well, it's binomial probability. Remember that when you have 2 outcomes, 2 possible outcomes for each event, and there's 4 events, it's 2 to the 4th power. And as we can see from our tree diagram, there's 1, 2, 3, 4 levels. This is a 4, the 4th level, 2 to the 4th, 16 possible outcomes. Okay? So, question 12, what is the probability she'll win at least 2 games? Okay, so this becomes a little more difficult. It's not that difficult. You just have to look at all the possible outcomes. Okay? So, our best bet on this one, whether you like it or not, is to use Pascal's triangle. Since it's binomial probability, let's do that. So binomial probability starts with Pascal's triangle. The ones flow down. This is 0 level, this is 1 level. We got to go all the way to level 4. We add the 2 numbers together, the 1 and the 1, to make it 2. And then we keep going down. This is 1, 3, 3, 1. And then finally, we come to level 4, 1, 4, 6, 4, 1. Sorry. Probability of 0 is going to be 1. Out of how many? 2 to the 4th. 16 possible outcomes. Okay? So it's 1 out of 16. Probability of 1 is 4 out of 16, which is 1/4. Probability of getting 2 is 6 out of 16. What's the question we're looking for? I think we've already answered it. Let's double check. What is the probability she'll win at least 2 games? Okay, so she just has to win 2 games. All right, so let's look. How many possible ways can she win 2 games? Does it say at least 2 games? So it's any way she can make more than 2 games. So what's the probability of winning 3 games? That's 4 out of 16. And the probability of winning all 4 games is 1 out of 16. Now, remember, we're basing this on all things equal. What we want to understand is only these are the ones we need to worry about, okay? So we just have to add those together. So let's do that. How does that come out? 6 plus 4 plus 1 all over 16. They have the same denominator, so I can do that. That comes out to 11/16. That is the probability that she will win at least 2 games, okay? 5 of the 16 games, she'll win either 1 or none, okay? So there you go. What is the probability of winning a trophy? To win a trophy, she must win at least 3 games. Let's go back to that schematic again. Guess what? We just take the 2 off. 3 plus 4 is 4 plus 1. It becomes, there's a 5/16 chance that she wins 3 games. Okay? Let's move on. Using the follow scenario to answer questions 14 through 15. Sherry gets an allowance of $10 per week. Okay? She's decided she needs more money, so she's made a deal with her mother in hopes of increasing her weekly allowance. She proposes that she will throw a dart at the dartboard. If she hits the board, she gets the original $10. Okay? First shot, if she hits the board, she gets the original $10. Okay? Plus another shot at the dartboard for an additional $10. On the second shot, if she hits the board, she gets the original $10 plus another shot at the dartboard for an additional $10. If she hits the board on the second shot, she adds $10 to it, okay? If she misses the first throw, she only gets $5. Sherry hits the dartboard 60% of the time. So Sherry's mom is worried about how often she'll be giving her daughter $20 a week. Given Sherry's stats, how many weeks will her mom be out $20? On the first shot, miss, $5. Make, $10. And a second shot. On the second shot, if she makes it, another $10. She makes a shot 60% of the time. 60% of the time on the first shot, 0.6, she's going to get $10. Okay? 40% of the time, she's going to get $5. She'll make another $10 60% of the time. And 40% of the time of the second shot, she's just going to make $10. Okay? We got to multiply this through. 6.6 times 0.6 is 0.36. So 36% of the time, she'll get $20. All right? 0.6 times 0.4, 24% of the time, she'll only get $10. But look at this. 40% of the time, she's going to get $5. Okay? Well, how many weeks are there in a year? This is where it becomes important. 52 weeks in a year times 0.36 is how much? We have to determine how many weeks she's going to make $20. So let's see that. 52 times 0.36, 18.72 weeks, or roughly 19 weeks. So 19 weeks out of the year, she's going to make $20. Given Sherry stats, how many weeks will her mom be out $20? 19 of those 52 weeks. How many weeks of a year will her mom only have to pay $10? Well, we go back to that schematic and we see that only 24% of the time does she have to pay the $10. That means it's 52 times 0.24, which is 12.48. So about roughly 13 weeks, roughly 13 weeks. She's going to pay $10. All right? So that makes it pretty simple, doesn't it? All right, let's look at this next one. You're eating at a bistro or Subway. Have narrowed down your sandwich choices to the items at the table below. You must choose one item from each category, and the estimated probability for each choice is included. Let's create a tree diagram to show all the possible choices to help you answer the question for 16 through 17. Okay? So let's look at this. Let's create that tree diagram they want us to do. So the first one we're going to do is bread. So we've got honey oat, which is 40%, 0.4. Wheat, which is 0.2. And white, which is 0.4. Now, I'm not going to go and do this for every single one, but I'm going to do the meat on this one. Meat, 1, 2, 3 choices. We have ham, turkey, and roast beef. 60% of the people get ham, only 10% get turkey, and 30% get roast beef. And then the spreads, 1, 2, 3, 4. You got mayo, mustard, ketchup, and ranch. Mayo, 30% of the people get it. Mustard, only 10%. Ketchup, 40%, and a rough 20% of the people get ranch. So now we've got some information we can help ourselves with. Let's take a look what the question is asked. How many outcomes are there? Okay, so the way you do that is you see how many options we have for each event and multiply through the events. We have 3 options for the bread, 3 options for the meat, and 4 options for the spread. So it's 3 times 4, and 36 total options. Okay? Next question. What's the probability of getting honey oat with ham and mayo or ranch? Okay? Honey oat, ham, mayo, or ranch. So you've got a 40% chance. We have to multiply the probabilities for each. So 0.4 times 0.6 times the sum of these two, 0.3 plus 0.2. 0.4 times 0.6 times 0.5. 0.12, or 12% of the time. There's your answer for that question. How often will you get a honey oat with ham and mayo or ranch? 12% of the time. Okay? Which of the following is part of an observational study? Is it a treatment, placebo, control group, or variable of interest? If we're looking at this from the perspective of it being an observational study, only experimental studies have treatments. Only experimental studies have placebos. Only experimental researchers put people into treatment and control groups, so that removes the first three. Guess what? Both experimental and observational studies have a variable of interest. So there you go. Your answer for that question is a variable of interest. Now use the following scenario to answer questions 19 through 20. The dentist in a dental clinic would like to determine if there's a difference between the number of new cavities in people who eat an apple a day and in people who don't. They're going to conduct a study. 50 clinic patients who report they routinely eat an apple a day and 50 clinic patients who report that they don't eat an apple a day will be identified. Dentists will look at their records to determine the number of cavities the patients have had over the past 2 years. Then they will compare the number of new cavities in the patients. 19. This study will have which of the following features? Will it have a treatment? Will it have participants? Will it have a control group? Will it have a placebo? The only answer that's true is a participant. And here's why. This is a survey. This is not an experiment. Yes, he delineates between people that ate an apple and people that didn't. But understand, he didn't give them any kind of treatment. He suggested that they may have treated themselves by eating an apple a day. But the point is, no treatment was given by the researcher. So the study is an observational study only. Read what he says. He will look at their records to determine the number of cavities the patients have had over the past 2 years. Yes, there you go. This is an observational study. So the only thing that's correct is the participants. That is the only correct answer for 19. Observational is the correct answer for 20. Use the following information for questions 21 through 24. You're thrown 3 fastballs. 3. You must hit them in the fair zone to count. If you hit all 3 in the fair zone, you win the big prize. If you hit 2 in the fair zone, you win a medium prize. If you hit 1 in the fair zone, you get a small prize. If you hit 0, you do not win and receive no prize. So what is the probability of winning a big prize? What is the probability of winning a medium prize or a small prize? What is the probability of getting nothing? And what is the probability of getting a medium prize? It's all Pascal's triangle. It's all binomial probability. We're going to build us a Pascal's triangle. You're throwing 3 fastballs, right? Zero, 1, 2, 3. Probability of getting 0, 1. Probability of getting 1 is 3. Probability of getting 2 is 3. And probability of getting 3 is 1. And that's all out of 2 to the third or out of 8. So 1 out of 8, 3 out of 8, 3 out of 8, and 1 out of 8. So the probability of getting a big prize is to get 3. So this is the probability of getting a big prize. Probability of getting a medium small prize is 3 out of 8 because you can only hit just 1, and that is a small prize. Nothing is 1 out of 8. Medium, 3 out of 8. Okay? So that's it. You just use Pascal's triangle to answer that question. It's really, really simple here. So those are your answers. Probability of getting a big prize, 1 out of 8. Probability of getting a small prize, 3 out of 8. Probability of getting nothing, 1 out of 8. And probability of getting a medium prize is also 3 out of 8. Okay. Jar 1 has 6 marbles in it. Jar 2 has 4 cubes. Find the probability of drawing out a red marble and a red cube without looking. Okay. So this is pretty simple. How many red balls are there and how many total marbles are there in the first jar? Okay. So jar 1, there are 2 red out of 6 total. The second one, red. There's 1 red cube, and there's 4 total. So 2 times 1 is 2. 6 times 4 is 24. 2 out of 24, 1/12. There's a 1/12 possibility of getting a red marble and a red cube. Okay? That's your probability answer for that question. All right, so you decided to attend Florida State University and are registering for classes. You're trying to get into one of Professor Sumner's calculus sections. Here are the times calculus is offered. Okay, Professor Sumner's has section 1, 8 and 9 a.m., section 2, 11 to noon, and section 3, 2 to 3:20, and so on. You only have room in your schedule for morning classes, anything that ends before noon, and you're assigned a morning section at random. What are the odds you end up in Professor Sumner's classes? So you're going to get a morning class, all right? So don't worry about anything in the afternoon. you're going to get assigned a morning class. That's what it says. You are assigned a morning section at random. So just the morning classes. So Professor Sumner's, he has one here. There's a morning class, and there's a morning class. So Sumner has 2 morning classes. All right? So, but how many total classes are there? How many total morning classes are there? That's what's important. 2 plus 3 is 5, plus 3 is 8, plus 1 is 9. Sumner has 2 out of the total 9 possibilities, okay? Now that should be your answer. Let's see, what does it say? 2 out of 9. What is 2 out of 9? 2 divided by 9 is 0.22. So your answer is A, 22%, okay? 2 out of 9, 22%. All right. You find out that all of Professor Sumner's classes are full, and you get assigned to another teacher's class regardless of it being in the morning or afternoon at random. What are the odds you end up with a morning class that will fit your schedule? Okay, so let's look at this chart again. Now, all Professor Sumner's classes are gone. Zhang has 4. Young has 4. So 1, 2, 3, 4, 4, and 2. So there's a total of 10 classes between Zhang, Young, and Clausel. How many morning classes are there? Well, Sumner has not, he's out of the picture. Zhang has 3, Young has 3, and Clausel has 1. That's 7 of the 10 classes are morning classes. So there's a possible 7/10 or 70%. That's your percentage. 7 out of 10 possibilities to get a morning class. All right, we're going to look at this area model. Toss a coin on it. Without looking, what are the chances your coin lands on a blue section? Okay, so if we look at this, what's the smallest size square we have? The small blue square and the small red square are the smallest. Well, these green, blue, 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 and red are all 2 sizes, and this green is 4. So if we're looking to see how many total, it's 4 times 4 or 16. What are the chances going to land on blue? It's something out of 16. Well, how many blue squares are there this size? This is 2, 4, 6, 7 out of 16. So the answer is 7 out of 16. All right. Mr. Price uses this following average for his pre-cal classes. Tests are 60%. Quizzes are 30%. Homework is 10%. Mr. Price decides to offer students a one-time chance to switch a new grading system and stay with the one listed above. New grading system, tests are only 50%. Quizzes are now 35%, and homework is 15%. Elvis has a quiz average of 76, a homework average of 90, and a test average of 87. What would be his average under each of the systems? Okay? What would be his average under each of the systems? So 87, this is how we have to do it. We're going to take the 87 and we'll multiply it by the 0.6. 87 times 0.6 is 52.2. 76 times 0.3 is 22.8. And 90 times 0.1 is 9. Okay? So add all those numbers together is an 84. Now let's do the second one. Okay? So 87 times 0.5 is 43.5. 76 times 0.35 is 26.6. And then 90 times 0.15 is 13.5. We'll sum those together, and that gives us an 83.6. So obviously, grading scheme number 1 is the best opportunity for this guy. All right, Elvis wants to use grading system number 1. So another one of Mr. Price's students, Chris, trying to decide if he should stay with the old system or change the new one. Let's see, his quiz average is a 74, homework of an 80, and test of a 76. 76 times 0.6 is 45.6. 74 times 0.3 is 22.2. And 80 times 0.1 is 8. So we're going to add 8 plus 22.2 plus 45.6, and that gives us a 75.8. How about the second part? 76 times 0.5 is 38. 74 times 0.35 is 25.9. 80 times 0.15 is 12. 38 plus 25.9 plus 12 equals 75.9. Well, in this case, Chris would be better to get grading system number 2. 31. It's Joe Blow's first season playing with the Marlins. He has 280 at-bats, 51 singles, 12 doubles, 29 triples, and 7 home runs. How many more triples, doubles, singles, and home runs would Joe need to have an 817? Round to 3 decimal places. Here's the thing. You have an option for 1 single, 2 doubles, 3 triples, 4 home runs, 4 singles, 6 doubles, 1 triple, or 5 home runs, or the correct answer is not here. Now, here's the cool part about this. You're given the answers. All you got to do is add those answers to what you already have and see if it adds up to above 0.817. So, A, 1 single, 2 doubles, 3 triples, and 4 home runs. So, let's see. 51 plus 1 is 52. 12 plus 2 is 14. 29 plus 3 is 32. And 7 plus 4 is 11. All right, that's A. All right, so what is the slugging average? Recall that the slugging average is simply the number of bases over the at-bats. 290 at-bats. How many bases do we have? Okay, so A, we have 52 times 1 plus 14 times 2 bases for a double plus 32 times 3 bases for a triple plus 11 times 4 bases for a home run, and that's over 290. Now we just have to add those together. So 52 plus 14 times 2 plus 32 times 3 plus 11 times 4, which is 220. And that you're going to divide by 290, and it gives you a 0.758. Not enough. So A's out. So let's scratch off A. Start over again. Start with B now. B. B is 55. 55 singles plus 18 times 2 plus 30 times 3 plus 12 times 4. And that's all over 298. 55 plus 18 times 2 is 36. Plus 30 times 3, which is 90. Plus 12 times 4, which is 48. It's 233 divided by 298. We said it was 0.7 something, right? Too low. 233 divided by 298 is 0.782. It's not enough. So the answer is C. The correct answer is not here. 32. Determine the degree of each vertex in the graph below. That's easy. Count the number of edges that go into each. B has 2 edges, okay? Right here. G, over here, has 4 edges. 1, 2, 3, 4. D has only 2 edges. 1, 2. C has 4 edges. 1, 2, 3, 4. That all intersect at C. Okay, does an Euler path exist? Does an Euler circuit exist? Does a Hamiltonian path exist? Or does a Hamiltonian circuit exist? Here's what you need to know about these graphs. Remember, if all vertices have an even number of degrees, then an Euler circuit exists. Also, if an Euler circuit exists, so does an Euler path. All right? So, B has 2, G has 4, D has 2, C has 4. We've already determined that. What about A, E, and F? A has 2, E has 4, and F has 2. They all are even. So A and B are fine. They work. A and B are fine. All right? That's an Euler circuit, which an Euler path also exists. How about a Hamiltonian circuit? So A to B, B to C, C to D, D to G, G to F, F to E, and E to A. So guess what? A Hamiltonian circuit exists too. And if a Hamiltonian circuit exists, so does a Hamiltonian path. So all A, B, C, and D qualify. Okay? All of them are yes. All right, determine whether each graph below is an Euler circuit, Euler path, or neither. Write which one is on the line. If the graph does have an Euler circuit or path, write or highlight the path to the vertices. All right, so Euler, 2, 3, 2, 3. An Euler path exists, but not an Euler circuit. Circuit would be all even. A path is 2 are odd and the rest are even. What is the path? It's simple. Start at D or B. Doesn't matter, one of the odd ones. B, C, D, B, A, D. We've touched every path exactly once, started at B, ended at D. All right. How about B? I has 2, J has 4, E has 2, F has 4, G has 2, H has 4. An Euler circuit exists. We know it does because there's an even number of degrees on every vertex. I, H, G, F, H, J, F, E, J, I. Just one example. How about this one? O is 1, P is 1, M is 1, K is 1. L is 3, N is 3. Guess what? Neither an Euler circuit nor an Euler path exists. Determine whether each graph below has a Hamiltonian circuit, Hamiltonian path, or neither. This is just plug or chug. We have to determine by just trial and error. Now, in this one, we don't have to touch every edge. We just have to touch every vertex. So A, B, C, D, A. Guess what? An Hamiltonian path and circuit both exist. On this one, no. We can't go into any one without being able to come back out. You can go to L and N, but you can go to K, M, or P if you start at O and you're stuck. So that's neither a Hamiltonian circuit nor a Hamiltonian path. How about this? Can we do a Hamiltonian path? Sure can. Look, start at G. G, F, H, I, J, E. We touched every vertex exactly once. Did we start and stop at the same one? No. So a Hamiltonian circuit does not exist, but a Hamiltonian path does. All right. That's it for the review. Best of luck on the test. Again, I want to remind you to please be sure that you're actually going out of your way to read the directions before you get started on the test. Be blessed, be a blessing.